Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to continue in our investigation on how to stretch and compress sine and cosine waves. In part one, in my previous video here, we talked about vertical change only, where we affected the amplitude and not the period. We first started with the parent function sine x, and then in our second example, we investigated cosine. Okay, so now we're in part two. We're going to take a look at horizontal change. So now what we do is we keep a equal 1. Okay, so a is 1 now, and we change b, okay? And then we'll see what happens. We do the same thing. We graph a bunch of points, starting off with our parent function first. Okay, so this is going to be our parent. We'll start off with sine, and then you guys can do cosine as well. And we'll see what happens. What kind of effect does b give on the function? Like when you change b equal to 2 or 1/2 right here, when you multiply the x by something, the x coordinate, which is your angle, okay? When you affect the angle, how does that affect the function? So, all right, so we're going to graph the parent function first. So here we go. We're going to do it in 3 different colors, just like the previous activity. Starting off with the parent function. So sine of 0 is 0. Okay, just look at the unit circle right here. You guys should know this. We're going to plot 5 points every single time. Always plot 5 points for any function. Sine of pi halves is 1, sine of pi is 0, sine of 3 halves pi is -1, sine of 2 pi is 0. So we plot the points. Before we do, we got to scale the axes. So here is 1, and here's -1. Now b is going to affect something else, and I'm not going to give it away. So, but we will have to change the x-axis here. Okay, so I'm going to, instead of going out 8 units and calling that 2 pi, I'm going to go out 4 units and call that pi. Okay, so I always go out 4 with multiples of 4 units. Okay, either 4, 8, or 12 or something like that. Because you always have to break your period down into 4 equal parts to graph a function. So pi, and then over here would be 2 pi, another 4 units. Another 4 units would be 3 pi, another 4 units. Okay, a little bit off the axis here, so let's stretch it out a little bit. And then go over 4 units. Okay, and there's 4 pi. Okay, so we got the y-axis vertically, you got your x-axis, which represents your input angle here on the horizontal. All right, so now let's plot. Okay, the first one's going to be in purple. Okay, and we're going to change colors on each one. Okay, so the sine, so this is pi halves here. Okay, and let me see. So sine of 0 is 0. Okay, we should know that. Sine of, oh, wait a minute, excuse me. Yeah, let me double check something here. Sine of pi. Pi halves. Oh, what am I doing? Okay. Yeah. Okay, so sine of 0 is 0. Sine of pi halves would be 1. I just thought I just lost my thinking right there. Sorry, it's in the morning. Okay, sine of pi is 0. Sine of 3 halves pi, which is here. Okay, 3 halves pi. Well, guess what? That's -1, and then sine of 2 pi is 0 again. So you sketch the graph, okay, and notice that we have 1 period of sine right here. Okay, it goes just like this. So this is my sine function. In purple right here, this is sine of x. This is my parent function. All right, so now how does changing b, which is the coefficient of x, change the function? Does it change the amplitude or the period? So let's find out. Let's take a look at b equals 2 here and see what happens. So now I take a look at sine of 2 times 0, which is sine of 0, which is 0. So it starts at the origin too, nothing changes there. Oops, I gotta change colors. So been doing this in all my videos, so let's keep on going here. All right, let's change the color. So this one's gonna be in blue. Okay, now we take sine of 2 times, okay, pi halves. Well, guess what? That's sine of pi, because these cancel, and that's sine of pi. Okay, so that is a 0 again. So pi fourths. Oh, you know what? This should be pi fourths, not pi halves. Fix this. This should be pi fourths. So let me change this. Just notice there's a little typo right here. Okay, so let me change that again. So let me reevaluate. Okay, so fix this right here. So 2 times pi fourths, that's what I want. Okay, so pi fourths is half of a pi, so there's, excuse me, half of a pi. Okay, so half of pi halves is pi fourths, or 45 degrees. So when you simplify this, all right, you get 2 pi fourths, or 2 fourths pi, or 1/2 pi. So this is the sine of pi halves. All right, we simplify. 2 fourths is 1/2, and the sine of pi halves, guess what? That's 1. So at 45 degrees, or pi fourths, we get 1. So I'm going to plot it here. So we start at the origin, then go right pi fourths up 1, and then you evaluate at pi. So a sine of 2 pi, guess what? That's 0. Okay, so pi comma 0 is on the graph. Pi fourths. I didn't change these values. This should be pi halves here. I should be going multiples of 45 degrees. 0, pi fourths, pi halves, 3 fourths pi. Yeah. I need to fix both of these, this one and this one. So let me reevaluate that. Okay, it's a little typo on I just found a little error on my main document. I got to fix that. So 2 times pi halves, guess what? That's sine of pi. Okay, and we're back to 0 again. So at pi halves, we get 0. Now we take sine of 2 times 3 fourths pi. So now we have to simplify that. All right, so 2 times 3 pi is 6 pi. 6 pi fourths is 3 halves pi. So the sine of 3 halves pi, after you simplify 6 fourths to 3 halves, that's -1. So at 3 fourths pi, which is right here, all right, we get -1. So it goes up and then down, and then now take sine of 2 times 2 pi. Well, guess what? That's the sine of 4 pi. Okay, that's 2 times around, and you get 0 there. So we're right back to the origin. So this one here goes up and then down all the way to the minimum, back up again. So now, check this out, my period for one period of cosine is not, sine is not 2 pi, it's pi. So it shrunk the period, it compressed it, okay? Okay, compressed the period. So the question is like, how do we know what to do? The normal period is 2 pi, but now it's pi. So how does B affect it? Well, if B is 2, it compresses it. Okay, what happens when B is 1/2? Okay, so now let's switch colors, and let's try this one. So here we get cosine of 1/2 times 0. That's cosine of 0 or 1. And then here we get cosine of 1/2 times pi, or half of pi. And guess what? That's 0. And then we take cosine of 1/2 times 2 pi. That's simply 1/2 cosine of pi, because a half of 2 is 1. So you get -1 there. And cosine of 1/2 times 3 pi. Guess what? That's cosine of 3 halves pi, which now you're at the bottom of the unit circle, and that's 0 there. And now we get cosine of half of 4 pi. Half of 4 pi, which is obviously 2 pi. So the cosine of 2 pi, right back, full revolution, and that's 1. So now let's plot. So at 0, we got to plot 0. Wait a minute. I did cosine there. I need sine. There's another typo. God, Ainsworth. Okay, so I need to fix this. There should be sine. What happened here? So this should be sine. I got to change all these to sines right here. So let me do that and reevaluate. Okay, so this is what happens when you run a video in the morning. So the sine of 0 is 0. Sine of pi halves, which is 1. Sine of 1/2 of 2 pi, which is the sine of pi, which is 0. And then the sine of 1/2 of 3 pi, or 3 pi halves, that's right at the bottom of the circle, and it's -1 there. And then the sine of 1/2 of 4 pi, so you get the sine of 2 pi, that's a full revolution, that's back to 0. Okay, so here we go. Let's graph this. I got to fix that. Okay, I'm not going to rerun the video either. I just fixed everything, and I'll fix the main document. Okay, so what do we have? 0, 0 is here, starting at the origin here, now looking green. Pi, 1. Okay, and then 2 pi, 0, back to the axis. 3 pi, -1 here, and then 4 pi, 0. So it looks like this. Here's one period of the function. All right, there we go. So now we have the period went from 2 pi now to 4 pi. So here we go. So now this one, the period is 2 pi. Just noticing here, just by looking. The previous one, when b is 2, period is compressed. So the period went to pi. So here, if you change b from 1 to something else, it doesn't affect the amplitude because the amplitude is still 1. It affects the period. All right, so let's write down the conclusion here. So explain the effect of b right here, which is called the coefficient of x in respect to the parent function cosine. Does it affect the amplitude, the period, or both? Okay, and then specifically, how does it affect the function when b is less than or greater than 1? Well, okay, we found that if b is bigger than 1, it compresses it. If b is less than 1, it stretches it, okay? So here we go. So let's write it out. So b, okay, affects, okay, only the period of the function. The period of the function. Okay, not the amplitude. Not the amplitude. Okay, if b is less than 1, okay, which, or b, let me do the first case actually. So when b is greater than 1, okay, like the second example here, if b was 2, it compresses it. Okay, so if b is greater than 1, it compresses, all right, the function. All right, if b is greater than or less than 1, like a half, for example, so b is equal to a half, all right, it stretches out, okay? It stretches, all right, the function. So it increases the length of the period. So the period in general, you got to take the original period, which is 2 pi, and divide it by b. Okay, so 2 pi is the period of the parent function, period of the parent function, in this case sine or cosine, and then b is called your coefficient of x. Okay, coefficient of x. So let's see, let's go back here and let's apply this right here. So going back to the second example here where b is 2, and notice in general it's 2 pi divided by b, but b is 2, so we have 2 pi divided by 2, which is pi. All right, for the third example here, when b is 1/2, we have p is equal to 2 pi divided by b in general, but b is 1/2, so you have 2 pi divided by a half, which is 2 pi times 2, or 4 pi. Okay, so remember, you take this right here, this idea, and you apply it to the function when b is different than 1, okay? That's how you can tell the period before you even start graphing, all right? So now you know. If b is not 1, then it stretches or compresses the period, and you find the period first and then use it, okay? All right, and then your job is to do basically the same thing right here for the next function. So we set it up here, and on this one here, on example 4, you're working with cosine now. Let's see if I made any typos here. Wow, I fixed it here and I forgot to fix it up there. Okay, so you're good. So on this one here, go ahead and scale the axes, 1 to 1, the y-axis from -1 to 1. And then again, go out 4 units, call that pi, and then 2 pi, and then out another 4 units, 3 pi, and then out another 4 units, and you go out to 4 pi, and then you can start your graphing, okay? So at this point here, you want to graph the parent function first. Okay, so let's do that. Let's graph the parent. And so cosine of 0 is 1, cosine of pi halves is 0, cosine of pi is -1, cosine of 3 halves pi is 0 again, and then cosine of 2 pi back to 1. So this one here, your parent function cosine starts on the y-axis at 1, and then it goes to, let me see, pi halves. Let me see, this is pi halves right here, so pi halves come at 0 here, and then at pi, you go down 1 unit to -1, and then you're at 3/2 pi here. And then 2 pi is up here, 2 pi comma 1. So when you graph cosine, it starts on the y-axis, and it decreases all the way to pi, and then it increases to 2 pi. So there's your parent right there, cosine function. Then, of course, you got to evaluate the other functions and graph the other functions. Okay, so pause the video right now and go ahead and work ahead, and when you're ready, go ahead and press play. And then check your work. Okay, so let's assume that, I'm assuming now that you've done your work here, and now we're just comparing here. So the cosine of 2 times 0, 2 times 0, that's cosine of 0 or 1. Here we get the cosine of 2 times pi fourths, which is 1/2 of a pi, and the cosine of half a pi is 0. And then here we have the cosine of 2 times pi halves, which is just the cosine of pi, or -1. And then here we have cosine of 2 times 3/4 pi. 6/4 is 3/2, so the cosine of 3/2, that's 0. And then here we have the cosine of 2 times just pi, and that's obviously 1. So we plot here, starting at 0, 1, and then pi fourths, which is here, at pi fourths, 0, and then at pi halves, it's -1, and at 3/4 pi, you're back to 0, and then at pi, you're at 1. So look at that. Just like the sine graph, it compressed it, okay? So when b is 2, we have a compression. Okay, we have a new period. It's 2 pi divided by b in general. So 2 pi divided by 2 is pi. So the period length is pi for this one. Period equals pi. All right, compressed. It's a compression. Now when b is 1/2, we expect something similar to sine, but let's go ahead and verify. Okay, so we'll switch colors and evaluate. All right, so here we go. Cosine of 1/2 times 0, that's cosine of 0 or 1. Here we have a cosine of 1/2 of pi, and that's 0. Here we have cosine of 1/2 of 2 pi, which is just cosine of pi, or -1. And then here we have a cosine of 1/2 of 3 pi, that's 3 pi halves, and that's 0. And then cosine of 1/2 of 4 pi, which is cosine of 2 pi, or 1. Okay, so this one also starts up here at the y-axis at 1, and then at pi, you get 0. At 2 pi, you get -1. At 3 pi, you get 0, and then 4 pi, you get +1. So here, just like the previous one, it goes down, it decreases all the way to 2 pi, and then from 2 pi to 4 pi, it starts to increase, goes all the way up at 1. So this is a stretch. Okay, so when b equals 2, we have a stretch. When b equals, b equals 1/2, sorry. When b equals 1/2, we have a stretch because it's less than 1. And then on the second one here, when b is equal to 2, we have a compression. Okay, and we have it changes the period. All right, and there we go. So let's write this out. Same thing like before here. So b affects, okay, only the period, not the amplitude. Okay, not the amplitude. And then what we have is if b is equal to 2, which is greater than 1, we have a stretch. So, a compression here. A compression, and then if b is equal to 1/2, which is obviously less than 1, we have a stretch. Okay, and in general, the period is always equal to 2 pi divided by b. So just keep that in mind. So going back to the last example here, if you were to figure out the period here, you take 2 pi divided by b. All right, b is 1/2, so you have 2 pi divided by 1/2, and that's 2 pi times 2, or 4 pi. So notice that the period's been expanded or stretched out. All right, so those are the two horizontal transformations of sine and cosine. All right, and just go ahead and practice that, and I will see you in my next lesson. All right, or see you in class. Take care. This is Ainsworth. Bye-bye.